Please welcome Cadence President and CEO, Dr. Anirudh Devgan.
Lose yourself in the music the moment you own it. You better never let it go. You only get one shot. Do not miss your chance to blow. This opportunity comes once in a lifetime. You better lose yourself in the music the moment you own it. You better never let it go. You only get one shot.
Hello, everyone. Morning. Welcome to Cadence Live. We have a super exciting program this year. This year, actually, we went to 2 days, given all the interest. But to kick it off, we have a phenomenal keynote session. Again, kicking off with my good friend, Jensen, who's here. Person who needs no introduction, the godfather of AI himself. Please welcome Jensen to the stage. Yeah.
Nothing can stop me. I'm all the way up. All the way up.
Anirudh. Ladies and gentlemen, Anirudh.
Jensen, you want to start? Hey, this is M2000.
Oh, is that right?
Yeah.
Oh, we built this computer together.
Yeah, yes.
3 tons. All right, am I signing here?
Yeah. Remember, Jensen signed another famous computer, 2012, right? Look at that. Let me sign my.
That computer is going to that's going to be worth 100 times more in a few years.
Okay, Jensen.
All right, great to see you guys. Which side am I?
This side.
This side?
Yeah. Also, the other super exciting thing in 26 is now we have a lot more of our products running on the Millennium 2000 with NVIDIA. Yeah.
Well, we're going to have everything running.
Exactly.
Yeah, we're going to accelerate everything. I mean, this is such an extraordinary time. You guys know that Anirudh is the only CEO in the world that grew up in high-performance computing, who grew up in algorithms, and who knew about the capabilities of CUDA long before. Yeah, it's really incredible. And
It's a great partnership, Jensen.
Great partnership,
Great
yeah.
partnership, right? And it's really remarkable to see, what NVIDIA has become. The most valuable company in the world. Of course, you are transforming multiple industries. So last year, we talked about, at that time, Agentic was just coming on, right? And of course, you had a fabulous keynote last month at GTC. But as you look back, like the evolution of AI over the last 6 to 12 months, and what do you see in the next 6 to 12 months?
Yeah, in fact, if you just go back, it literally was only 2 years. In the 2 years' time, we went from generative AI. This whole thing started kicking off with generative AI, ChatGPT. Generative AI was such a big deal because it was able to, of course, we solved perception long before that. But generative AI was a big deal because it was able to generate tokens, which is foundational to 2 things. The ability to think, right? You can't think if you can't create words, generate words in your mind. And then number 2, the ability to interact with other tools, external tools. And so it set the foundation for reasoning, which was next, and then agentic AI. Generative AI, ChatGPT really created the foundation of that. We're now at a point where agents are able to perceive, reason, and execute plans. The reason why this is such a big deal is because AI intelligence is interesting. People who know-it-alls, who understand it all, know-it-alls, are interesting but not valuable. People who can do things are valuable. And so AI went from knowing everything, being able to spew out all kinds of knowledge and information, to now it's able to use tools, which is why it's such an incredible time for Cadence. It's such an incredible time for the industry because we can now have AI that use tools. And if you ever profile, we use AI, agents are just all over our company. Our token use is going exponential. And if you profile what the agents are doing, the moment it reasons about what it has to do, it spins off tools. And we got all kinds of agents, and we're working with you on chip design agents, and we're going to have all kinds of ASIC designer agents, whether it's verification, which is the first one, chip stack, and analog chip designers, back-end chip designers. We're going to have all kinds of agents, and the thing that's going to be incredible is the tool use of the EDA industry. The tool use of Cadence is just going to skyrocket. Yeah.
Yeah, that's actually a very good point because this worry last few months in the market that AI is going to replace tool use, right? So this.
Yeah, that's right. And there are, of course, software companies are now categorized. You need to categorize software companies a little bit better. There's some software companies that are focused on workflow automation. Workflow automation, of course, you could argue that a lot of that is going to be augmented by AI. But Cadence and many software companies, particularly engineering, EDA, the software is not workflow automation, it's fundamental tools. These algorithms are not going to be, you're not going to rediscover a better one. These are excellent algorithms that have been refined over time, and they're fundamentally grounded, and it's integrated into all of our companies, and we can't have agents coming out with random other ones. We want them to use the tools that we have. And so the tool, in this case, agentic systems, this agent revolution, this inflection point of inference is going to drive adoption, drive consumption of tools. Your industry and my industry is limited by one thing, which is the number of ASIC designers we have. In my case, the number of ASIC designers we have limits how many products we could create. In your case, the number of ASIC designers I have limits how many tool licenses if we need. Well, the number of ASIC designers is likely to increase by 1,000 times in the near future. And so this is going to be an extraordinary time for tool industries like yours.
By the way, you had a great analogy. Remember we was talking a few weeks ago, and you had this robot analogy coming to your house. I love that analogy, that if you have a robot come to your house and it has to warm up a food, do you do it with your hands or you use a microwave that's already there?
Yeah, tool use.
Yeah.
The ultimate expression of agentic systems, we have agents, which are digital robots. We're going to have physical robots that we're working on. And suppose we just created the world's most amazing physical robot. And they come to our house. Are we going to create a physical robot that has microwaves beaming out of its fingers, or its hands turns into a 100-pound hammer, or they're just going to pick up a hammer, use the microwave, use the dishwasher. They're going to use tool use. And so tool use, agentic systems is defined by the word tool use. They're going to use existing tools. And we need to be grounded on those tools because in the end, I got to know whether the answer is right. And I know how to use Cadence. And so if it uses Cadence and I use Cadence and everything is put back into Cadence, then I can come back and I can verify it, I could collaborate with it, I can fine tune it, so on and so forth.
And Jensen, it's great to work. Of course, you are always ahead of, the one thing remarkable about you is not just, AI outside, but, you're driving the industry, but also how much you apply inside to improve your own. And of course, we have worked with NVIDIA for a long time to always try to improve the design process. And so we announced ChipStack, as you may know, a couple of months ago, and with NVIDIA, and like Jensen, you're saying, the first use case was RTL and verification, because that's kind of a natural thing.
And this agent knows PCI Express protocol, which is extremely complex, by the way, and memory interface protocols and CXL protocols, and basically the APIs of chips. This agent specializes in the language of chips and understands all the complicated protocols, and it's built on top of that understanding so that it could do verification with us. Yeah, it's really incredible. Nothing is more frustrating than a PCI Express bug.
Yeah, exactly. Because verification, that's
chase
one
that
thing.
one forever. Do you guys agree?
One thing remarkable about chip design is how much effort we put in verification. Because of course, software industry, there's
100 to 1.
Yeah.
It takes one person to design it, 100 engineers to fix it.
And that's something that the software industry doesn't do as much, right? Like the pure software. But in chip design, with RTL design, the verification part is super critical.
Yeah.
So of course, we are very glad to work with you and your team on ChipStack. But now, in the last few
we have
months,
a bunch of engineers. They have all these different names, and then we have a bunch of engineers. The name's Cadence.
Yeah, exactly.
And they're on Slack channels with us. Slack channels with us.
Virtual engineers.
Virtual engineers. And I love that all the email addresses that start with Cadence, they do exactly what I want.
Yeah, exactly. But Jensen, even the real engineers from
I
Cadence
work with them
do-
24/7. Just in the future, my Slack channel will be 99% Cadence.
Yeah, thank you. Yeah.
I got Cadence agents talking to other Cadence agents.
By the way, even the real Cadence employees do what you want, not just the agent.
Yes. Thank you. Thank
Yeah.
you. Thank you.
Now, more recently, we have two new super agents,
Yeah.
that we're working with NVIDIA.
Yeah.
Of course, the back end,
Yeah.
because, what I keep hearing from customers, like especially NVIDIA, you have this amazing cadence now every year, and the chips get bigger, so the amount of PD work goes up in the back end.
Yeah.
And then the other big thing is analog. Analog design has always been very difficult to automate.
Yeah.
So we have this new virtuoso agent, ViraStack, that we work with your
That's
team.
right.
So I'm super excited to what happened in these two new areas apart from
Yeah,
just
those are really great choices. The challenge with physical design, there's an impression for people that are outside the industry that we design the chip, and then at some point you have a net list, and you take that net list and you do place and route. Well, these chips are so large. If you think about chips the way you think about cities, each one of our chips is like all the cities in the world combined, and you're doing city planning while the buildings are being created, while everything is being designed. And so we plan physical design from practically the beginning of the design process, because that's how long it takes. You're in the physical design process for 2 years. And the reason for that is because, of course, the amount of technology, amount of components that fit into the physical design that you have to place is large. But you have a fundamental bin packing problem, and you're trying to optimize for size, you're optimizing for manufacturability, you're optimizing for timing. Meanwhile, everything's being designed at the same time. It's an incredibly challenging process. And so now we have agentic systems that help us basically work 24/7, but you're paralyzed to work across thousands of agents, and I'm hoping. And today we're scaling it up to tens and hundreds, but we'd like to scale it up to thousands and hundreds of thousands of agents all working around the clock, trying all kinds of different permutations so that you could solve this many variable, impossible to find a perfect answer, optimization problem. And so this is an ideal place for agents. Analog design is very similar to that. The design space is extremely large, and it's hard to know when you're pushing the limits of analog design. We're basically at the limits of physics, and there's a lot of different permutations, a lot of different ways you could design the analog circuitry. Having agents explore the space for us, simultaneously design for signal integrity, for power, for size, for manufacturability, exploring all of that simultaneously across all the agents. These are all exploration problems. And so I think there's a misunderstanding about fundamental design, that you have a problem statement, you come up with a solution like you're solving a puzzle, and that's the answer. Well, it turns out, there are 1,000
exactly.
plausible answers, 1,000,000 plausible answers. The question is, which one are you going to go and optimize towards? Well, having more agents, having you explore the design space, the better.
And that has been history of EDA and chip design.
That's
because
right.
like you have said before, there's no one right answer. There are thousands of right answers. You have to find the one with the best PPA.
That's right.
So anything that helps find the best right answer is invaluable
That's
in
right.
the design process.
It's a search algorithm, and one of the most complex search algorithms in the world. We're going to need a lot of agents to help us do that.
Yeah.
Yeah.
Super exciting. So Jensen, also, you talked about at GTC, by the way, that was great keynote. This
Just a warning to all the companies. Your tool use is going to skyrocket. You better secure your licenses soon.
Yeah.
Call your Cadence salesperson right away.
Yeah.
Yeah, the tool, which is I think we all know that. The number of computers are going to skyrocket. The number of licenses of software tools are going to skyrocket. Agents. We've historically been both of us have been limited by butts and seats. In the future, we're only limited by compute.
Yeah.
And so
more virtual teams.
That's right. Yeah.
And one thing you mentioned in your keynote, which was very interesting, of course, the explosion of inference that is caused by agents. But also you said, in the future, every company or every employee, you would give them a token budget, or I look at like an automation budget, because they will be assisted by agents and tools. So that's a very different thinking. You want to make sure that the employees we have become super employees with the help of agents and more. So how do you, how do you put that to practice? I think it'll be good for the companies to know.
Well, right now across the company, we're encouraging everyone to use Claude Code, Codex, and Cursor. Those are the three most important things to us. And in the case of, and we're getting extraordinary success with Codex. Codex 2 is coming, and so I'm super excited about that. We have early access to that. That's going to work incredibly well. Claude Code, as we know, completely revolutionary. And so every single engineer, if you're now using one of those three tools, I got to ask you, why aren't you using one of those three tools? And these agents and we're seeing great success all over the place. Zero touch automation across so many different domains. But the one thing that's happening, of course, is that every engineer is orchestrating a whole bunch of agents, which are using a whole bunch of sub-agents. And so, for example, ChipStack would be a sub-agent that we're calling on to do verification. And Vera and right? All of those are going to be sub-agents that we're going to call. And so the number of agents that we have solving problems, automating things, and yesterday I heard, I won't describe too much what we're actually doing with it, but converting from one code base to another code base, completely functional, zero touch. It would have taken 10 years, 10 engineers a year to do, literally did in 5 hours, and completely zero touch. And we're seeing this across the company. Our token use, of course, is going skyrocketing, which is fantastic, because ultimately, we wanted to hire more people anyways. And now we automate through agents, made every single engineer more productive. The net result of that is, back in the old days, you might ask your VLSI team, well, how many people do you have? Not that more is better, but one is not enough. And so you know that. And so you kind of have a feeling for how large VLSI teams need to be, how large place and route teams need to be, how large your library team needs to be, and so on and so forth. And so you have a feeling for that based on the amount of work that you have to do. We have a complete reset now. Now, based on the people that we have, I want everybody to be maximizing the agents that they are orchestrating to automate their work. And if they have mastered the work of orchestrating agents, by definition, their token use is going to go up. And so at the end of the year, if somebody said, my scope of responsibility is this, and my group used no tokens, that's no different than somebody coming up to me as, my VLSI team is going to build Feynman. And I said, oh yeah, how many VLSI engineers do we have? 3.
Right.
I know that's obviously the wrong answer. And so you're obviously not, one of two things are going to happen. You don't understand the problem, or Feynman's not going to show up. And so we have the same, you need to have the same sensibility now about post-agentic leadership, post-agentic engineering, post-agentic company building. If a company isn't spending in our case, if we're not spending, right now we're already spending hundreds and hundreds of millions of dollars of tokens a year. If we're not spending billions of dollars of tokens a year, obviously we're not going to be producing the things that we're doing. And so those are new sensibilities that are coming in.
Right. And the other good thing with this agentic framework is of course we will have some specialized agents like for RTL verification or analog, but NVIDIA can mix and match their agents with it, right? Because anything which is specific to NVIDIA or specific to Feynman. So
I'm super interested in artificial general intelligence. That's interesting. But I need specialized agents that are great at place and route, because that's my life. I need special agents that know how to design and verify. That's my life. And so in one case, I'm interested in it, I enjoy reading about it, I don't mind using it. On the other hand, our company has critical needs, and those specialized agents has to be the world's best. And that we're counting on you to build them.
Exactly. No, we are ready. We are ready, Jensen. So this will be the next great, chapter in our collaboration is this new agentic flows. And also, like we discussed, a few months ago, we also recently acquired, a physical AI, simulation software from Hexagon.
MSC.
Yeah, MSC.
Yeah. Terrific. Good job.
Yeah, thank you.
Yeah, smart.
It's one of the is one of the original solvers in the industry.
That's right.
And we had
multi-dynamic solver.
yeah, and then they have one of the great products for multi-body dynamics.
That's right.
For robotics and cars and all
Yeah.
that.
And we worked with them
Yeah,
before you bought them.
exactly. Yeah, thank you. Yeah.
And then he buys them. I kind of figured it out.
Yeah.
He's watching who I'm working with.
Yeah.
Clever.
Same thing, actually.
I'm watching who you're working with.
Yeah. If you remember, we also worked with this Stanford company, Cascade, on CFD. Which
Yeah.
was doing great work.
Yeah,
on GPU.
fantastic.
We bought that one too.
Okay.
Yeah.
Incredible. So smart.
But and you have
Yeah,
talked a lot about.
those are some of the pioneers. And one of them, in the case of MSC, is a pioneer in physical AI. AI that understands physicality, understands the laws of dynamics, understands the laws of physics. And then the other one is AI physics, which is AI that's pretending to do physics, emulation of physics. One is physical AI, the other one is AI physics. And we started with agentic AI, just AI. Now we're working on AI physics and physical AI.
Exactly.
Yeah,
Embedded agentic systems.
incredible.
Embedded.
Embedded, yeah, physically embodied
And
agents.
that's going to be huge. I know we've talked about it for years. I think that could be huge. It could be as big or bigger than the first wave
Yeah.
of all this physical AI.
Well, the industry's larger.
Yeah.
I mean, if you look at the world's $100 trillion industry, the vast majority of it is physical AI. It has to understand physicality in order to do its work. And just as we had the ChatGPT moment, the generative AI moment for language, we've arrived at the generative AI moment for robotics. It's called VLA, Vision Language Action Model, which basically is perception in, action out. Just like we had words in, words out, we now have words in, action out. Pixels in, action out. So we now have the generative AI moment, and we include reasoning to it so that we embody this robot with human knowledge priors. So for example, it could do reasoning about things like, if a ball's rolling across the street, don't go chase it. That reasoning system is embodied in our words somewhere. And so using chain of thought, the same reasoning systems that we created for language, you can now decompose a very complicated scenario into simple scenarios that we know how to perform. People who are good reasoners are able to encounter a brand new circumstance that has never been experienced before, that you've never described, never learned from, but you can, through reasoning, you can decompose it into simple things that you can address and you can solve. And so we've now embodied two things: generative capability into the robotic systems, VLA, and reasoning models into it, so that it could be very functional, even though trained on relatively small corpus of previous knowledge, because a lot of that reasoning system is embodied in the language model. And so these two capabilities, now we combine that with advances in mechatronics, extremely good motors, and that's advancing incredibly fast. Boom, robotic systems are here. And it's multi-embodiment. You can teach one AI model to deal with the whole body, and it works with wheels, it works with 2 wheels, 4 wheels, 1 wheel. I mean, it's incredible. Yeah, the AI just figures it out. Just like we learned how to ride a bicycle ourselves, we embody the bicycle. We learn how to drive a car, we embody the car. We can learn how to use a unicycle, we embody the unicycle. We learn how to play tennis, we embody the tennis racket. We now have figured out how to do that generally, artificial general robotics that modeling system we now understand. And so,
Right.
yeah, physical AI has arrived.
And
It's
you have
just
a
around the
big,
corner.
you have
2
a
years
big
from now.
effort on it, right?
Huge effort. Yeah.
big- And you
Huge
talked
effort.
about, yeah. And then I think one thing there, which of
And
course,
so we're partnering on that.
Yeah.
And so NVIDIA has a large team of engineers working with Cadence, large team of engineers, and you're creating simulation systems and you're connecting it to your principal solvers, which Cadence is world class at. And so and of course the MSC team, we're working with you across the board on robotic systems.
Yeah. No, that's super exciting. Because one thing, like just for the audience, to train these VLA models, the data is not as readily available as it is to train LLM models.
Yeah.
Because LLM models, the data is on the internet. But for physical data, either you have to capture it, which takes a lot of time, but the right way to generate is synthetic data.
That's right.
Like Cosmos and Omniverse and
That's right.
Isaacs. But the synthetic data has to be the more accurate it is, the better the model will be. So what we are working together with NVIDIA, thanks for that, is to embed MS Adams, which is a very accurate physics simulator, together with Cosmos.
That's right. And so just imagine how you would teach someone how to play tennis or golf. So the first thing, of course, they have to have general capability. They have general manipulation, general articulation capability. And so you train that, you develop that through one of two ways. One is through imitation, and that's where you use teleoperation or say, watch me do something, and so that's imitation learning. The second part is creating synthetic data through principled solvers, which is the part that we're working on, and the principled solvers simulate essentially articulation, manipulation, so on and so forth, and it's all physically based because it obeys the laws of physics. So inertia is obeyed, friction is obeyed, contact is obeyed, so on and so forth. And so the second part is simulation. And the third part, we use these two capabilities and we train a world foundation model. And that world foundation model, trained well enough, at some point, it could start generating synthetic data. And this is no different than, as I'm explaining this, you imagine how you learn how to do things. You learn through imitation. You learn through people explaining the first principle logic and mechanics to you, and then at some point you might even just dream about it. You're simulating in your mind. If I did this, what would happen? If I did that? Well, you're using synthetic data generation, and so we're doing the same thing with models. They generate synthetic data, mountains of it, and then from that mountain of data, we then can memorize it, basically learn it into a small model.
Exactly.
So that small model could take all this giant amount of data, petabytes and petabytes of data, and it compresses it, encodes it, learns it into a small model.
Because one thing, I've talked for physical AI for a while, and people used to say like, whoa, this is not, this few years ago, we said, no, it's not going to happen. What are you talking about physical AI? But now, especially with cars, it's starting to happen. And I know NVIDIA has
announced
a huge,
this thing called Alpha Mayo.
Yeah.
It's the world's first reasoning car, and it's incredible. We turn, reason out loud, and so we just tell it to reason out loud. It's driving in San Francisco, and of course, when we tell the car to reason out loud, it just reasons about everything it sees, and so it talks continuously. You don't want a driver. It's like having a chauffeur, just literally everything. I'm going to stop now. Car coming from the left, I'm going to wait. You don't have
like
to
the mental
Yeah, it's like a chauffeur that literally tells you everything. Okay, and so we turn on the reasoning mode. It speaks to us, and we're driving everywhere, and it's reasoning about things. It's there's a truck parked in the middle of the lane. The other lane, no car is coming. I think I could go to the other side. Go around. I mean, now there's a chauffeur, autonomous vehicle, just talking to you, continue. You could tell it to shut up, and then we do. And then, but the point is, now we have reasoning systems, and the number of diverse environments that it could navigate through is incredible. And so this is really the next, and this is Anirudh's vision. The first time you and I met, Cadence was a EDA company working on electronics and chips and things like that. And you imagine that, in fact, the future of the world is going to be full stack. And in a lot of ways, you and I see it exactly the same way.
Yeah.
It's going to be, if you're an engineer designing a chip, you have to understand the software stack on top, the systems it goes into, the applications of the system beyond that. you have to be a full stack company because nobody's going to go figure that out for you. How would you even design a chip to do so? And in our case, we're trying to design the system to do so. In your case, you're trying to create tools to enable me to do so. And so both of our companies have to be full stack companies. And so if that's the case, then Cadence has to move out of the chip into systems, move out of the system into factories, and we're partnering together on AI factories,
Yes, yes.
the world's largest computers. You know,
Oh, that's great. By the way, the recent results I saw,
So
we have
good.
Cadence Reality that simulates and optimizes. And because I think you told us a few months ago, one of your big problems is tokens per watt, right? And we worked on that problem. And
we are the leaders of low token cost, by the way.
Exactly.
I produce the lowest cost tokens in the world. It's an expensive system, I'll acknowledge that. But it produces so many
Exactly.
tokens. It's the lowest cost tokens in the
it's
world.
a great partnership on and it's getting
The
better
more
and better.
you buy, the more you save.
Exactly. Somebody said that, right? You need to have a
If
special.
you buy enough of these things, you're going to be rich.
You need to write a book with all your sayings, Jensen, at some point.
I crack myself up sometimes. so,
But
so
he is
anyhow-
very funny. I'm sure most of you know that, right? He is funny in all your talks you give are pretty funny, and in person.
the world's
you're
funny to me.
Yeah.
You know, you see people do something, you say, that's just funny. You know, why people do, why the industry is the way it is. You go, well, that's hilarious. You know, what a dysfunctional group. You know, and so that's hilarious. So everything's a little funny. But I think just to ground our conversation and our partnership, I think it all started literally with a dinner with Anirudh. And by the way, when Anirudh is excited, that's what he looks like.
I'm always excited.
After 2 martinis, that's what he looks like.
Yeah.
No change. So anyways, we
Well, you
talked
have
about.
good taste in martinis.
You're right.
Monkey 47.
Monkey 47.
Yeah.
If you have to drink martini,
yeah,
Monkey
yeah.
47. And so it started with us talking about how computing has been reinvented, and how you wanted to reinvent Cadence, and our partnership really evolved from that moment. And I'm really grateful of the work that we're doing together because fundamentally, the tools that you create for me enables me to realize my dreams. And so I can't realize my dreams without the Cadence team helping me realize my dreams. And this is such an incredible moment because we reinvented computing. That's why NVIDIA's here. And because the EDA industry, the design industry, is built on top of computing, now it's reinventing Cadence. And in the short period of time that we've been talking about agents, and you've been working on agents, now agents have been realized. People now understand what it means. And so 2 things, I think, happened. We reinvented the engineering process, of course, but 2 amazing things happened for Cadence. And this all happened in literally 2 years since our martini. And this tells you how valuable the martini moment is. In that 2 years, Cadence now has an infinite number more chip designers, engineers that could use Cadence tools. So your TAM exploded because of that reason. And second, because you're expanded well beyond chips into the physical world, into where the largest industries in the world. The chip industry is large, but the rest of the world giant. And so now Cadence is going to help every company design everything that they make. So congratulations, good job.
Thank you, Jensen. Thank you for the partnership. It's a true honor, right? Yes.
Thank you. Anirudh.